To understand computer files, we need to understand actually what programmers refer to permanent storage. They refer to permanent storage as persistent storage because one can retrieve it or remove it, which is deleted by the user, of course. So you need to understand the difference between temporary, being our RAM, which is temporary, and our permanent storage, which is like what is saved on our external hard drives, what is saved on a DVD, persistent storage. So when we talk about a computer file is saved in persistent storage. And what is a computer file? Well, a computer file is a collection of data stored on permanent storage devices such as your computer's hard drive, which is also a hard drive on the cloud, DVDs, USB drives, and maybe even a reel of magnetic tape. There are two broad categories of files. The one is a text file. And what is a text file? Well, text files are just a combination of numbers, names, and salaries, etc. that can be read by a text editor. The reason why we have to use a text editor is because it is saved and encoded using a scheme such as your ASCII Unicode. Our second category of files is a binary file, and you should be familiar with binary files. Those are your images and music. Now, what are our files measured? Well, they are measured in bytes. So what's quite difficult is to remember is that 1 byte is only 1 character. A kilobyte is thousands of bytes. So a kilobyte, for instance, would be 1,000 letters or roughly a 150-word essay. A megabyte, which is a million of bytes, well, a megabyte will be millions of letters. A gigabyte would be billions of letters, and a terabyte trillions of bytes. So what is quite important is how you can actually see this is that a byte can be 1 rand, which you can hold in your hand. Kilobyte, yeah, you can hold 1,000 rand in coins, but when you get to megabyte or gigabyte or even a terabyte, you would not be able to hold so much coins in your hand when you worked with 1 trillion of bytes or 1 trillion of coins. Now I ask you, what are the common characteristics of all files? Now to answer this is we have to look at our attributes of our files. And what are our attributes? Well, our attributes are basically going to be our name, it's going to be the date modified, and it will be the type and file size. Those are our common characteristics of all files, our attributes as such, so our variables as such. Okay, so now you've got a whole lot of files. You want to know, how do we actually organize these files? Well, that's pretty simple. Files are actually organized by storing them in directories, which we also call folders. Directories are a more general term, and what's interesting is that directories only started becoming called folders when we introduced Windows 95. Now, what are directories and folders? Well, they're just basically organization units on a storage devices. What we do is how to find out where our files are. Well, we use a path, and a path is basically a combination of disk drive plus the complete hierarchy of directories. So here would be our path over here, which is just basically your disk drive, which is your local C, as well as some of the hierarchy like sample files of those directories. We've got C is our disk drive, logic is a folder, sample files is also a folder, and our payroll data.dat is our text file, which is our file. All right, let's discuss data hierarchy. Now, what is data hierarchy? Well, data hierarchy describes the relationships between data components. And our data hierarchy components consist of characters, which is your letters, your numbers, and your special symbols. Then you get your fields, which is your single attributes of a record, and that's composed of 1 or more characters. So an example would be your last name or your annual salary, etc. Then you get your records. Well, your records are groups of fields that go together for some logical reason, such as your name, your address, your salary. Those are all grouped together for a logical reason as it defines who you are as an employee, your salary, your address, your name. Then you get your files. Well, your files is basically groups of related records, such as tables. Everyone in the class's records will go into a file called students.dat. Then those files can be grouped together even further into a database. So your database holds the related files, and they will be your groups of files or tables to serve the needs of an organization. And all these tables can be linked by a field like ID number, for instance, or student number, for instance. We do not cover this in this course. It will be done furthermore later on. Now we've got our files. Now we want to actually perform some file operations, perform operations on these files that we have stored. Well, we use data files in your programs. And these data files, you just need to understand the several file operations. Well, we get 5 file operations. The first operation is declaring a file identifier. We do that as such. We do an input file identifier, and that will be employee data. And we'll have an output file, updated data. These identifiers are internal to the program. And please note that they are capitalized in the program to our input and our output. Our second operation is opening a file. Very important. We're opening a file from storage device, and we're using the employee data variable name. Opening the identifier, note the file name as well as the extension we have here. There are quite a few extensions. We've got .text, .doc, .java, .pdf. In this course we do the .dat, but I'm quite happy with .text as well if it is a text file. If you know what file you're working with, then it's .text file. But if you don't know what file working with pseudocode, then you'll just use .dat. Well, the third operation is reading from a file and processing that data. Well, we input the name from employee data, we input the address from the employee data, and we input the pay rate from the employee data. When we are inputting name, address, pay rate, we can all do that in one line from employee data. We are taking the name, address, and pay rate in that current line of that file, and we are inputting it into a box of memory. So we're reading it first, but we're actually still putting it in, the values in something. That's why we use the word input or read interchangeably. The last 2 operations that you do is writing to a file and closing a file, which I'll discuss just now. But firstly, I need to discuss reading 3 data items, the name, the address, and your pay rate from a storage device into memory. How does this actually work? Well, this is our text file. We have our name, our delimiter, which is a comma here. We have our address field, and we have our pay rate. Notice we can't use white space as a delimiter here because within our address here we have a white space. So white space wouldn't work for a delimiter in this particular text file. That's why we have a comma as our delimiter. And recall, a delimiter is just basically something that divides each attribute in our file. So what we're actually doing, if you have a look here, we have a CD with our Matthews 47 Maple 17. So what we're actually doing is we're taking those when we input name, address, pay rate from employee data. We are taking it and we putting it in within our box of memory. We're taking the address and putting it in within our box of memory. We're reading 17, we're taking it and we are putting it in our pay rate box of memory. So we are stored in memory at the appropriate name or location. So that is why I say it is incredibly important that when you write your name, your address, your pay rate, so when you are reading data from a file, this must correspond to how your data was saved within the delimiters. So it was saved name, address, pay rate, not address, name, pay rate. So you can't go address, name, pay rate here if it is saved as name, address, pay rate. Very important. So just as I discussed that we have our name, address, pay rate, we've got our file operations that have to be in sequential order. Now what I mean by sequential order is, the only way I can actually describe what sequential order is if I had to explain to you how your music was saved on a cassette tape. Remember when you had a cassette tape back in the days? Google it. If you wanted a particular song, let's say song number 15, you had to forward from song 1 all the way to 15 to listen to song 15. It wasn't the same as how you do now on your iPods. You would just click on song number 15 using your touch screen. It wasn't like that. Data files that we work with now are in sequential order. And when I say sequential order, I mean that the program reads all the records in this file from the beginning to the end, processing them one at a time. So here we are processing Matthew's data first, and then we're processing Smith's data next. Then we're going to process Zimmerman's data, then we're going to process Garcia's data. So now we've processed all this data, we've got all this data, it's all been copied from our text file into our data file, into memory. Now we need to sort it. So what do I mean by sorting? Well, sorting is basically the process of placing records in order by the value in a specific field or fields. So we could sort by name, or we could sort by address, or even pay rate, for instance. Our fourth operation or file operation which we have to do is writing data to a file. So we've sorted it, we've done what we needed to do to it, we've done our manipulation to the data. If they had an increased pay rate, we've given them an increased pay rate. Now we've got to write that data to file. And what I'm doing is that I've got to store data into a computer file on a persistent storage. And how we do that is we write it to file. So we're going from RAM, which is our random access memory, to file. And how we do that is we use output name, address, pay rate to our updated data file. If you recall, we opened it up, or we declared the identifier right at the beginning, our updated data. So we're saving all the information which we have just updated to our updated data. Why not just update it to the original employee data? Well, simply just that. It is our original. It is basically our backup file. So we have outputted our name, address, pay rate to our updated file, and that is our backup. It's a copy kept in case values need to be restored to the original state. And the backup copy is always called the parent file, and the newly revised copy, like our updated data, will be our child file. Last but not least, I think what we need to do is our last operation is always closing every file you open. So here you'll see in our pseudocode here, within our finish module, we close our employee data and we close our updated data file. Here is a flowchart to show you what happens. Is within my declarations, we have to create an identifier for our input file and our output files. We have to do our housekeeping, and within our housekeeping we always open our data files, and then we input the first field from our employee data. Then we return back to the main menu or mainline logic, and then we start our not end of file, which is our loop, and we're going to loop and loop and loop until we reach the end of file for our employee data.dat. Within our detailed loop, this is where we are updating our pay rate to our raise, which is $2, and then we output that field which we are working with, we output that to our updated data file. And then we input the next one, and we manipulate that, their pay rate, output that to the updated data, and we repeat that until employee data.dat has reached end of file. Our finish is our last procedure, and our last procedure is always to close our two files that we are working with.
Another interesting note is the default input and output devices which you can see within front of you is your keyboard and your monitor. We do not need to open and close the keyboard or monitor after using it.
It's already done in your operating system.